Good morning. Today we are going to analyze the series and the parallel circuits to do or to solve them. But before we start, let's now distinguish between the series and the parallel circuit. Let's remember now the series circuit. The current in the series circuit is the same in every resistor. That means the current at the first resistance, the first resistor equal to the current in the second resistor equal to the total current in the circuit. And but the voltage here, we call that the voltage will be distributed. Or we can say that the series circuit will be the voltage here, the voltage distributor. That means the summation or the voltage in the first resistor will be different than the voltage in the second resistors, and the summation of the voltage in each resistor will be equal to the total voltage. This is for the current, this is for the voltage. Now let's talk about the resistance. The resistance, or to find the total resistance here, just you have to add the individual resistance, such as R1 plus R2 plus R3, and so on, will be our total. But for parallel here, it's not like the series. For the parallel, the voltage in each resistor will be equal to the total voltage. But the current here will be distributed. That's because the summation of the current in each individual resistance equal the total current. And to find the total resistance, just add the resistance, the reciprocal of each resistance, such as 1 over R1 plus 1 over R2, and so on. This is how to find the total resistance. And both of the parallel and the series circuit, when you solve them, they go above the concepts of Ohm's law, which is delta V, or V equals I times R. So series, this is the series circuit here. Thus you have only one path. The parallel, that you have many paths for the circuits. Today, we are going now to analyze these circuits to find the currents at each resistance, to find the voltage and each resistance, and how also here to distinguish between them. How can I know if this is series or parallel? Next week, inshallah, we are going to talk about combined circuits. Combined circuits, that's when I have series and parallel at the same circuit. Let's start now with the first example here of how to analyze mathematically the series circuits. Look at here now. Here you have the voltage, 60 volts. This here, as you see now, we have a current that is coming up from the voltage source. Now, look at the current. So how can I know if this is series or parallel? Look at the current here. The current is going on the first resistance, continue down on the second one, continue on the third one. So how many paths for the current here? Is the current here distributed or have only one path? It's come like this. It has only one path. So one path, it means this is series. Now let's go to talk about this example here. Here now, it's going here, and in the second and in the third resistance. I told you now, if we have only one path, this will be series. And if we have greater or more than two paths, this will be parallel. So here now, how many paths for the circuits?
3.
You have a 3. Yes, a 3. That means this will be a parallel circuit. So from here, I will not tell you this is parallel or series. You have to know. Why you have to know? Because if you want to find the R equivalents, you have to see, can I add them or can I add the reciprocal of them? That's why you must distinguish between the parallel and the series circuits. Now, let's start now with this example here. As you told me before, this is an parallel, this is an series circuit. Let's start now to fill the blanks. Let's start with the first one, how to find the R equivalent here. Now, R equivalent, since it is series, will be the summation of each resistance. So it is R1 plus R2 plus R3. This is how to find the R equivalent. Now R1, 17, R2, 12, and R3 is 11. 33 plus 17 will be 50. 30, this is 23. This will be 40. Sorry. So here now we have 40 ohm. So the first one here, you have to find the R equivalent. Now, why we have to find the R equivalent? This is in order to help me to find ITotal. For each circuits, we have to find R, I, and V. R, we find it, the R total. And we find the V total. Oh, it is here. But I need now to find R total. So why we find the equivalent resistance? In order to help me to find the total current on the circuit. How to find the total current? As I told you before, you have to use Ohm's law. Ohm's law, V equals I times R. So in order to find I total, you have to find R total and V total. If you find the V total and R total, you can find I total. The V total here is 60. From where? From here. The R total, we found it before. It is 40 times I total. So I total will be 60 over 40, which you can say it's 3 over 2 or 1.5. So the total current here is 1.5 ampere. For the first two blanks now, is it clear? Or are they clear how to find the R equivalent and how to find the I total?
Yes, teacher.
Okay. Now let's continue filling the blanks, but here you have to focus with me. Now, as I told you before, it is a series. So since it is a series, so we have only one path. One path, that means we have the same current in each resistance. So I1 will be the same as I total. And I2 will be the same as I total. And I3 will be the same as I total. Because we have only one path. So one path, it means we have the same current that pass in each resistance. It comes 1.5, and continue here 1.5, continue here 1.5, and come back to the voltage source with 1.5 ampere. So if you have series circuit, we have the same current in each resistance. Now, but the voltage will be different for each resistance. So let's find now the potential difference or the voltage of here, delta V, it's mean potential difference or the voltage here. V1, that's mean the voltage on the first resistance. V2, it's mean the voltage on the second resistance. And V3, it's mean the voltage on the third resistance. So here, that's mean, imagine now you have a voltmeter. You bring this voltmeter. Let's have here our voltmeter as an example. This is now our voltmeter. When I told you now, find the current on the first resistance here, that's me. I have to bring the voltmeter now and put it on the R1 to find, in order to find the V1. So I need to find the voltage. I bring my voltmeter now and put it in R1. So to find now V1, let's go now and use Ohm's law. Ohm's law, that's helped me to solve the series or the parallel circuits. V is I times R. V1 is I1 times R1. Now where is I1? We found it here. It is 1.5 ampere.
1.5 times 17.
And where is R1? R1 is 17. So let's multiply now. 1.5 times 17. You get a 25.5. So 25.5 volts. This is for the first, the first resistance. Now let's find the second one. The second one we have to do the same, but now you have to bring my voltmeter now. Connected here. I cannot, I don't know, I can't connect it now. I mean, you have to put it here in these 2 points, but I cannot rotate it. So just put it here. Now to find V2, I2 times R2. Now where's I2? It is 1.5.
1.5.
And where's R2? It's 12. So now 1.5 times 12 will be 18 ampere. 18, sorry, volt. Now let's find V3. The same steps now. Just to bring the voltmeter, put it here in order to find V3. So V3 will be I3 times R3. Now where is I3? It is 1.5. Whereas R3, it is 11. So 1.5 times 11 will be 16.5. So now I analyze the circuit. I find the R equivalent and I find the I total and I and V in each resistance. Now, in each resistor, sorry. Now, let's come here. They told me that the series circuit is a voltage distributor. Now, what does it mean? That means we have to check if V1 plus V2 plus V3, is it equal the V total? I mean, is it 25.5 plus 18 plus 16.5? Is it equal 60? If it is yes, my solution is correct. If it is no, there's something wrong. So let's try now add 25.5 plus 18 plus 16.5. You add them, you'll find that the summation here is 60. So this is correct. Is it clear?
Yes, teacher.
Now let's solve another example. Here now we have the same. We have it as R1 is 11, R2 is 7, and R3 is 20. And the voltage or potential difference, total potential difference here is 12. The first step, we have to find R equivalent. Let's fill the blanks now. R equivalent, it's mean, since it is, now let's first here, we have, this is the potential difference, this is the circuit. the current now. So how many paths we have?
One path.
One path. Since we have one path, so that means we have series circuits. Series, so the R equivalent will be R1 plus R2 plus R3. Now where is R1? It is 11. R2 is 7 and R3 is 20. So 18 plus 20, 38. So the R equivalent here will be 38 ohm. Now let's find the ITotal. I told you, since we have we found the R equivalent, we have the voltage to the total voltage. That's helped me to find the ITotal. Which formula shall I use? Ohm's rule. V is I times R. ITotal, I have to find it. So we can say it is V over R. Now where's the V total? It's 12. Oh, where's the R total? It's 38. Let's divide them now.
0.31.
So it will be 0.3157. So we can say it's 0.32. So here now, 0.32 ampere. So I have now the R equivalent. I have now the I total, which is 0.32 ampere. Now let's find the I. It's at each resistance. And let's find the voltage and the current at each resistor. As I told you before, series, so the I at each resistor will be the same as the total current. So that's mean I1 will be 0.32. I2 will be 0.32. And I3 will be 0.32. So after we found now I1, I2, and I3, after we find the current at each resistor, now let's going now to find the voltage at each one. V1, V2, and V3. As I told you before, to find V1, going back to use Ohm's law. Now, to find V1, you have to multiply I at the current at resistor 1 times the voltage that times resistor R1, sorry. I1 times R1, sorry. So I1, it's 0.32 times R1, which is 11. V2 will be the current, which is 0.32 times R2, which is 7. And V3 will be the current 0.32 times V3, which is 20. So 0.32 times 11 will be 3.52. Now here, since we have a decimals, when we add them, it will not be exactly 12. It could be close to 12. So now let's find V2, which is 0.32 times 7, which is 2.24. And to find V3, we have to multiply it by 20, which is 6.4. So V1 will be 3.52. V2 will be 2.24. And V3 will be 6.4. Now, let's check if the R resistance approximately equal 12 or no. Let's check now if the voltage at each resistor, when we add them, the summation of them are equal the V total or no. What we have to do to check them, let's add these three values. 3.52 plus 2.24 plus 6.4. 6, 5, 9, 11, 6, 12. So we're going to be 12.16, which is approximately 12 volts. So that's correct. Is it clear?
Yes.
Do you have any question for the series circuit?
No, teacher.
Okay. Now, let's now analyze the parallel circuit. For the parallel circuit here, we have R117, R212, and R311. The voltage total here is 60 volt. We have to find now the R equivalent for them, the I total, the I at each resistor, and the voltage at each resistor too. Now, to find R equivalent here, I'm sorry. So here now we have the parallel circuit. We have the voltage total 60, as I told you. Now here we have the same resistance and the same voltage, and in this example, 17, 12, and 11. Now let's see how the R total will be less than the R equivalent in the parallel if we have the same resistance, the same resistors. If we arrange them in series, we get a greater total, R greater equivalent greater than if it is in parallel. Now, so here we have the same 17, 12, and 11, but here they are arranged in parallel, but here they are arranged in series. Now, let's find the R total. As I told you, since we have this is the voltage source, so the current will be distributed here. So we have 3 paths for the current. Path 1, path 2, and path 3. Then they are come here, they are ordered now in 1, then come back to the voltage. So here, since we have 3 paths for the current, so we can say that this is a parallel. Now, to find R equivalent here, we have to say it is, it is series, so I'm sorry. Let's now remember that. To find, we have to say 1R, R equivalent will be 1 over R1 plus 1 over R2 plus 1 over R3. This is for the R equivalent here. Now, where's R1? It is 17. So let's go to be, it's 1 over 17 plus 1 over 12 plus 1 over 11. This will be 1 over R equivalent. So now on the calculator here, 1 over 17 plus 1 over 12 plus 1 over 11, we get the answer as 523 over 2,244. Now this answer is the same as 1 over R equivalent. So what did I need? I need R equivalent. So to find R equivalent here, you have to find the reciprocal . So in order to find R equivalent here, you have to write the reciprocal of this number. So here, after we add them, we get this answer here. So to find the R equivalent, as I told you, you have to write the reciprocal of this number. So when you flip it, you will find that the R equivalent will be 2,244 over 523, which will be 4.29, or you can say 4.3 ohm. So the R equivalent here will be 4.3 ohm. Is it clear?
Yes, teacher.
This is here how to find the R equivalent. Now, as you remember, in the previous example here, when we have these numbers, but they are these resistors, but they are arranged in series, the R equivalent was 40. But here we have it as 4.3 since they are arranged in parallel. So that's mean when you arrange the same resistance in parallel, you will get an R equivalent less than when they are arranged in series. Now let's find the ITotal. The ITotal here, to find it, we have to say that ITotal will be the VTotal over the R equivalent. Or you can say that VTotal is I times R equivalent. You have the same formula. Now VTotal is 60, R equivalent is 4.3. So let's divide now 60 over 4.3. You will get as 13.95. So you can say it is 14 volts, 14 amperes. So here now we have it as 14 ampere. This is the ITotal. Now, since here the current will be different at each resistance, so we cannot say that I1 is equal to I2 equals to I3. In the previous example, we take this number and we rewrite it or copy it in I1, I2, and 3. But here, since it is parallel, we cannot make this step because the ITotal or the I at each resistor will be different than the ITotal. But you can, here there's a thing can help me that the V1 equals V2 equals V3, which equals the VTotal. So here, just write this 60. Sorry, this 60 now. Just write it here as 60 volt. Repeat it here as 60 volt. And repeat it here as 60 volt. Because the voltage here will be the same at each resistor. So now we have the voltage, we have the R. We can now find the I, the current at each resistor. How? By Ohm's law. Let's come back now to Ohm's law. Ohm's law told us that I1 will be V1 over R1. I2 will be V2 over R2. And I3 will be V3 over R3. This is how to find the current at each resistor. Now, V1, it is 60 over 17. I2 will be 60 over 12. And R3 will be 60 over 11. Because the current here is distributed. Now let's divide. 60 over 17 will be 3.5 ampere. And 60 over 12 will be 5. and 60 over 11 will be 5.45, or can say 5.5 ampere. Now, so I1, we found it as 3.5 ampere, I2 is 5 ampere, and I3 will be 5.5 ampere. The current now is distributed on each resistor, but after they finish distributing, they are connecting now here in this point and must have the same current when they enter. I mean that the current, the I input must equal the I output. When they are going in, before going inside the resistance, we have 14, and after they collected in this point, that means if we add these numbers, 5.5 plus 3.5, we have as 9, plus 5, we have as 14. When we add them, we must get 14 ampere. So when they are going out, they are collecting at this point as 14 ampere as the total current when they are enter the resistance. So here now we find that I1 is a 3.5 ampere, I2 as 5, and I3 as 5.5 ampere, but the voltage here will be the same at each resistor. This is for the parallel circuit. Is it clear?
Yes, teacher.
Okay. Now, since here we have only 2 minutes for our period, tomorrow, inshallah, next week, we are going to solve the parallel circuit, how to find them, and also analyze the combination of the series and the parallel circuit. Do you have any questions?
No, teacher, thank you.
Thank you so
No,
much.
teacher, thank you. Have
Thank
a
you.
Have a
nice
nice
day.
day.